3.79c. It's on page 98. They give us this notation, 5D, and they asked us to determine the quantum numbers. So this notation gives you information about the first two quantum numbers. Once you know that, you can at least say something about what the other quantum numbers are, but you can't know for sure what the other quantum numbers are. So what we can say from this is n equals 5, because the number in that notation, when you see a number plus a letter when you're talking about electron configurations, the number tells you the principal energy level, quantum number. And so the electron, if it's in a 5D, is in the 5th energy level away from the nucleus. And then we also said, depending on whether it's an S, P, D, or F, that determines the value for L. The L quantum number, if it's an S subshell, is 0. If it's a P subshell, is 1. If it's a D subshell, is 2. If it's an F subshell, is 3. So if I'm talking about a 5D, I also know L is equal to 2. So it doesn't directly give us any information about the ML quantum number or the MS quantum number. So we can't know exactly what they are, but we can at least describe limits for what the number could possibly be. So what are the possible values for ML? Close. Right. So the values for ML range from negative L to positive L. So we can say that ML is either negative 2, negative 1, 0, 1, or 2. So it's not, I should put an or in here because it's not all 5 of those values. It's one of those 5. Right, and there are 5 values here because there are 5 orbitals in any D subshell. Right, a subshell is an area within an energy level. Within that energy level, you've got a smaller area called a subshell, and most subshells have even smaller areas called orbitals. Right, so within any D subshell, there are 5 smaller areas called orbitals that come together to collectively make up a D subshell. And then for MS, there's only ever 2 possibilities for MS. That's it. So if I don't know any information beyond this notation here, I don't know which of the 2 I'm dealing with, but it's either 1/2 or negative 1/2. As we'll see a little later today. The only way to know what the MS quantum number is for an electron is if it's either given to you or if you happen to know the MS quantum number for another electron in the same orbital. So if you have 2 electrons in an orbital, that's the maximum number of electrons any orbital can hold. Right? An energy level can usually hold more because that's a larger area. Within the energy level, there's a subshell. Most subshells can hold more than 2 electrons because most subshells are made up of multiple orbitals. But the smallest, when you break that down to the smallest amount of space, we're talking about where the electrons are located, any orbital, that's as detailed as you can get in terms of the location of the electron. So any orbital can hold a maximum of 2, and it's impossible for 2 electrons in the same orbital to have the same spin. So if I happen to know that this electron in the 5D had a partner with it in the same orbital with a plus 1/2 spin, then this electron would have to have a negative 1/2 spin because they can't both have the same spin if they're in the same orbital. But if I don't have any information like that, I'm just looking at one electron that happens to be in the 5D, I don't know whether it's a plus or a minus spin. Good question. Question? Yeah. Uh-huh. So there's no relationship between what ML is and what MS is. So once you know L is 2, because you're talking about a D subshell, you know there are 5 possible values for ML. Which one you have depends on which of the D orbitals the electron is in within that D subshell. So within a D subshell, there are 5 orbitals in there, and those orbitals have a specific shape and a specific orientation in space. If you're not given information about that, you don't know which of those D subshells the electron's in. So each of those D subshells, each of the D orbitals in the D subshell have their own ML quantum number. But we're not going to get that detailed. We're not going to get down into which of the D orbitals has the quantum number for ML equal 1 and which has the quantum number for ML equal -2 or whatever. But we know that each orbital can only hold 2 electrons. So if I wanted to fill this 5D subshell, since there are 5 orbitals in any D subshell, and each orbital can hold a maximum of 2 electrons, that means I have a maximum of 10 total that could fit in there if I were to fill up all of those orbitals. And also we know no 2 electrons in the same atom can have the same set of all 4 quantum numbers, right? So if I do have an electron in this atom that has n equals 5, L equals 2, and ML equals -2, there are 2 electrons that could possibly have those 3 quantum numbers, because when ML equals -2, you're talking about 1 orbital that has that quantum number. So I could fit 2 electrons in there. So I could have 2 electrons in the atom that have n equal 5, L equal 2, ML equals -2. But they can't both have the same value for MS. Or alternatively, I could say, let's say I've got 1 electron with n equals 5, 1 with L equals 2, 1 with ML equals -2, and 1 with MS equals 1/2. Let's say I wanted to put another electron in there that also had MS equal 1/2. What could I say about NL and ML? Well, if we assume that this electron's still in the 5th energy level, n has to be 5. And if we assume it's still in the same subshell, L would be 2. But it's not possible for all 4 quantum numbers to be the same for 2 electrons in the same atom. So if I did have this electron here, this other electron with these 3 quantum numbers, it would not be possible for it to also have an ML equal to -2. It would have to be either -1, 0, 1, or 2 for that other electron, assuming that their MS quantum numbers were the same. So I don't know what it would be, but it wouldn't be -2. It may be -1 or 0 or 1 or 2.